This is the key to section 4.1 part 2, and again we're looking at graphing exponential functions. Now remember what the graph of an exponential function looks like. So we have something that has this shape. I'm going to go ahead and use this. So at some point it goes, one part of the exponential function goes towards a horizontal asymptote. So for example, it could look like this, and then rises very rapidly. It could flatten this way, right? And on this side it rises rapidly. It could do this, and it falls rapidly, or it could do something like this. All right, but it has that general shape. All right, meaning that one part of it gets closer and closer and closer. It looks like it flattens out, which it doesn't, but it's still getting closer and closer. The y values are changing to a horizontal asymptote, just like this side. Okay. All right, so that's going to be the general shape of these. And remember, the form of an exponential function is this. So f of x equal b to the x plus c. So notice that the exponent contains a variable, so hence the idea of exponential function. We also note that this constant right here, this constant is your horizontal asymptote. So the horizontal asymptote, I'm going to call it HA for right now, the horizontal asymptote is going to be y equals c. And remember, the horizontal asymptote is a dotted horizontal line, and we name a horizontal line with the equation y equal a constant. Okay? All right, so one other thing you know about all exponential functions is that I can use any real number for x. It does not matter what real number I use for x, I'll get a y value back. So the domain is all real numbers. So we say negative infinity to infinity. And then I can always determine right away what the horizontal asymptote is. So the horizontal asymptote in this case is negative 5. So we say y equal negative 5. Now don't just say negative 5. You got to say y equals negative 5, especially in my math lab. It will mark it wrong. You won't get any points if all you do is just say negative 5. So you have to say y equals. It's a horizontal line. Now the y-intercept, since the domain's all real numbers, x equals 0 is in here. And remember, to find the y-intercept, you let x be 0. So it's always, all exponential functions will have a y-intercept. So to find, we let x equal 0. And so therefore I get y equals 2 to the 0 minus 5. So that's 1 minus 5, which is a negative 4. So the graph's going to cross the y-axis at negative 4. And if you want to write it as an ordered pair, you can. Does not matter in this case since I didn't mention it. So right away I note that my horizontal asymptote is y equals negative 5. So I'm going to go ahead and draw it. So here's y equal negative 5 right here. So let's go ahead and draw that horizontal dotted line. All right, so we're going to get something that looks like this. All right, so make sure you do that. Make sure you draw the horizontal dotted line. All right, so we're here. So at some point my graph's going to get closer and closer to whatever the graph does. It could be above, below, does not matter, but at some point it will get closer and closer. One part of the graph is going to get closer and closer to this horizontal asymptote. Okay? All right, now I found my y-intercept, so the graph crosses the y-axis at negative 4, so that's this. So that means in this case that the graph is going to be above the horizontal asymptote. Now one other thing that you remember is that if you look at the base, see where the exponent is just x? Now look at the base. Since the base is greater than 1, 2 is bigger than 1, this is going to be an increasing function. So f of x increases since the base is greater than 1. Okay? So that means that if I were to do a t-table, which I do because I need to apply 3 points, I already have 1. If I let x be 1, let x be 2, let x be 3, and 4, and so on, these y values will increase. That's what that means. My y values are getting larger and larger and larger. And you'll see that. So when x is 1, notice what happens. Y equals 2 to the first minus 5. 2 to the first is 2. 2 minus 5 is a negative 3. So I'm going to plot the point 1, negative 3 right here. Right here. If x is 2, I get y equals 2 squared minus 5. So that's 4 minus 5, which is a negative 1. So I'll plot the point to negative 1. Do you see your y values are increasing? Negative 3, negative 1. All right, so I'm going to plot the point to negative 1. And you can actually see it here, right here, where your y values are getting larger and larger. If x is 3, I mean, I just needed 2 more points. I had this plus these 2, but I'm going to go ahead and do 3 just to show you something. If x is 3, I get y equals 2 cubed minus 5. So that's 8 minus 5, which is 3. So you see that the y values are increasing, right? Okay, so I get 3, 3, which is right here. All right, and so I just, okay, so then I just go ahead and draw my graph like this. And what happens on this side? On this side, it gets closer and closer and closer to the horizontal asymptote without touching or crossing. So there's your graph, okay? So that is f of x equal 2 to the x minus 5. And remember, you had this before when you talked about shifting, vertical shifting. Do you see that negative 5 takes 2 to the x, would take 2 to the x and shift it down 5 units, and so that's where you get that horizontal asymptote. Okay? All right, now let's talk about the range. So the range, remember the range is a set of y coordinates. All right, so don't make the mistake and say that the range starts at bracket negative 6, because it doesn't. I'm sorry, negative 5. It isn't bracket negative 5. Remember, the y value never is negative 5. It gets closer and closer and closer to negative 5, but never is negative 4.999999999 and so on. Okay? So we have to say parentheses negative 5 to infinity. All right? Okay, so that was number 1. Now let's get number 2. So same idea with number 2. Domain of all exponential functions is all real numbers. All right, so I have an exponential, the variables in the exponent. The horizontal asymptote is this constant right here, so y equals negative 6. Since I know the horizontal asymptote, I can go ahead and draw it. So at negative 6, here's my horizontal asymptote. So go ahead and draw it at this point. Something like this, dotted line. All right, and I can easily find the y-intercept. So the y-intercept, remember all exponential functions have a y-intercept, so you let x be 0. And it has a y-intercept because the domain's all real numbers. So I get y equal 1/2 to the 0 minus 6. Well, 1/2 to the 0 is 1, and 1 minus 6 is a negative 5. All right, so if you want to rise an ordered pair, you'd say 0, negative 5. So that's here, right? That's right here. So I know that the graph's going to be above. Now let me remind you something. Remember in the previous problem right here, we said since the base was greater than 1, it's going to be increasing. What do you notice about the base here, 1/2? Well, the base is less than 1, right? 1/2 is less than 1. So that means that f of x is decreasing. And you're going to see this in a little while as well. So that means it's going to do something like this. That's what that means. So on this side, it'll flatten out, so to speak, and on this side, it'll rise very rapidly. Okay, so let's look at the t-table. So let x be, let's say, 1. If x is 1, I get y equals 1/2 to the first power minus 6. And 1/2 to the first power is 1/2. 1/2 minus 6 is negative 5.5, right? So 1, negative 5.5. 1, negative 5.5 is right here. You see that? So it's going to do this right here. So I know what's going to happen this side. So as x gets bigger and bigger and bigger, these y values are getting smaller and smaller and smaller. I'm sorry. These y values are getting closer and closer and closer to negative 6 without being negative 6. All right. Okay, so it's decreasing. So meaning that the y values are getting smaller and smaller and smaller. Okay. So as x goes to infinity, your y values are decreasing. See, this y value is let's say 11. This is 9. and so on. So what's happening? Getting smaller and smaller and smaller. But it eventually gets closer and closer to what y value? -6, without even going past -6. All right, now let's pick a number on this side, -1. Now use your calculator for that one. So you get y equals 1/2 to the -1 minus 6. All right, use your calculator. So on your calculator, you're going to say in parentheses 1 divided by 2, close the parentheses, say raised to the -1, all right, and then minus 6. Press equal, and you get -4. So -1, -4 is on this side. All right, I need one more point, so let's say -2. So I get y equals 1/2 to the -2nd power minus 6, right? So in parentheses, you say 1 divided by 2, close the parentheses, raised to the -2, okay, and then minus 6 equal, you get -2. So I'm going to plot the point -2, -2, which is here, and that's about all you need, and you just draw your graph. Make it look like it's increasing rapidly, though, something like that. All right, and so therefore your range is going to go from -6 to infinity. -6 to infinity. All right. Now notice that the base, well, one takeaway I need for you to get from here is that the base was 1/2, which is less than 1. So that means your function is decreasing, which means that all these y values are getting smaller and smaller and smaller and smaller. You see that? In fact, it gets smaller and smaller to -6. All right. So that is the key to 14.1 Part 2.